Colligative property. Colligative properties of liquid solutions. So first let's understand what are colligative properties. What do we mean by colligative properties? See, whenever we make a solution, what happens? Some properties of solvent change. Properties like density, like boiling point, etc. These properties change, their values change. Like for example, if I take water, pure water has boiling point of 100 degrees centigrade and pure water has a density of 1 gram per ml. Now if I dissolve, let's say NaCl in pure water, I make a solution. Boiling point density of this solution will not remain 100 degrees and 1 gram per ml. Both boiling point and density will change. Correct? So this is the first thing we should understand, that whenever we make a solution, what happens in a solution? Some properties of pure solvent change. Now, out of all the properties which change, a few of them we will call as colligative properties. So what will be special about colligative properties? That let's understand. So what are colligative properties? What are colligative properties? Change in which does not depend on identity of solute. मतलब वो इस पे नहीं डिपेंड करेंगी कि क्या सॉल्यूट डाला है, what is the solute. They will not depend on that. They will only depend on amount of solute. कितना solute डाला है, only on amount. Correct? So such properties we will call as colligative property. Like for example, if I take two samples of pure water in two different beakers. So originally when it is pure water, density of each sample will be 1 gram per ml, correct? Now let's say in first sample, I dissolve 1 mole of NaCl. And in the second sample, I dissolve 1 mole of KCl. Now both I have made a solution in both samples, in both beakers I have made a solution. And density of both beaker now will change from 1 gram per ml, correct? But the new density in both the beakers will be different. It will not be same to each other, correct? Now, if density is different, it means the change in density depends on identity of solute. It is depending whether the solute is NaCl or the solute is KCl, correct? So such a property we will not call as a colligative property because here the change is depending on the identity of solute. क्या solute है उस पे change depend कर रहा है. So it is not a colligative property. But on the other hand, if I will measure boiling point of both the solutions now, I will find both will be different from 100 degrees. Both will be higher than 100 degrees, but they will be equal. They will be equal to each other. So what does this tells us? This tells us that the change in boiling point does not depend on whether the solute was NaCl or the solute was KCl. It is same in both cases. It is just depending on amount. So therefore, we will say this is a colligative property. So I hope definition is clear to you. What are colligative properties? Change in which will not depend on identity of solute. It will only depend on amount of solute. So the four colligative properties which we will study are the four colligative properties which we will study are elevation of boiling point, depression of freezing point, osmotic pressure, and lowering of vapor pressure. Okay. And one more important thing here. We had said that colligative properties will depend only on identity of solute, only on amount of solute, will not depend on identity of solute. So here we have to be very careful to observe that whether the solute is dissociating inside the solution or not. Suppose I put 1 mole NaCl in water. Once NaCl enters in water, it dissolves in water. It will break into Na plus and Cl minus ions. So effectively number of foreign particles, apart from solvent in the solution are 2 moles. It is 1 mole Na plus and 1 mole Cl minus. So there are 2 different moles of particles, correct? So we have to take care of ionization or dissociation and association of solute. So to take care of that, we introduce a term which we call as Van 't Hoff factor, which we will denote by I. Okay. So this term will take care of dissociation or association of solute molecules in a solution. How is Van 't Hoff factor given? So Van 't Hoff factor we will give by relation. I is equal to 1 plus y minus 1 into alpha. Here, y is So Y is number of particles obtained by dissociation or association of one solute molecule. And alpha is degree of dissociation or association. Okay. So this is alpha. And overall, we can calculate I by 1 plus y minus 1 into alpha. What will be significance of I? What will I tell us? So, if in a solution, I dissolve n moles of solute, n moles of solute will be equivalent to Ni moles of particle. Means if we dissolve n moles of solute, I will calculate colligative property by Ni mole. Okay. So, like for example, let's say I dissolve 1 mole NaCl, which is 100% ionized. 1 mole NaCl, which is 100% ionized. So how will I calculate I? NaCl will dissociate as Na plus and Cl minus. So Y here will be 2 and 100% ionized means alpha is given 1. So Van top factor will become 1 plus 2 minus 1 into 1, that is 2. So if we dissolve 1 mole NaCl, we will calculate colligative property by 2. Because 1 mole NaCl will effectively behave as 2 mole particle. Another such example we can take, let's say, 1 mole Al2SO4 whole thrice, which is 70% ionized. So now, Al2SO4 whole thrice will dissociate as 2Al3 plus 3 sulfate. So Y here becomes 5 and alpha is given 70%, so 0.7. So Van top factor will become 1 plus 5 minus 1 into 0.7, which will be 3.8. So if we dissolve 1 mole aluminium sulfate, we will calculate colligative property by 3.8 mole. And see, there will be several cases where there might be association also. The solute molecule may make a dimer or a polymer. Let's take an example of that form also. 1 mole acetic acid in benzene. Solvent is benzene. In benzene, acetic acid undergoes a dimerization reaction. So 1 mole acetic acid, let's say 40% dimerize. So here how we will write the reaction. Dimerize means 2 molecules of CH3COOH are combining together to make a dimer. Okay? So now how we will write Y? Y how we defined? Number of particles obtained by dissociation or association of one solute molecule. Now here we are getting one particle by two molecules. So we will be getting half particle from one molecule. So Y value is half and degree of association is given 0.4. So here Van 't Hoff factor I will be 1 plus half minus 1 into 0.4. So that will become 0.8. Correct? So you can see in cases of association, both Y and I will be less than 1. Whereas in cases of dissociation, both I and Y will be greater than. So this is Van 't Hoff factor. Another relation regarding Van 't Hoff factor also we can write. Van 't Hoff factor can also be given as the theoretical molecular weight upon observed molecular weight of a solute. Okay. Now, let's see the 4 properties which we were discussing. The 4 colligative properties. What were those properties? First colligative property was elevation in boiling point. So basically what we are saying here, that boiling point of a solution is greater than boiling point of pure solid. Like pure water has a boiling point of 100 degrees. If I dissolve some salt in water, its boiling point will be definitely more than 100 degrees. Correct? And how is the change given? The change in boiling point, delta T is given by KBMI. Here, small m is molality of the solution. You remember what was molality? Molality was moles of solute by mass of solvent in kgs. I, we have just now discussed. I is Van 't Hoff factor. Okay. And Kb. Kb is a constant. Kb is a constant known as molar boiling point elevation constant. or ebullioscopic constant, and its value is given by Kb is equal to RT naught square by 1000 Lb, where T naught is R is universal gas constant, T naught is normal boiling point of pure solvent, and LV is latent heat of vaporization per gram of solvent. This per gram is important because generally latent heats are given to us per mole. So we have to be careful that in this formula, we have to substitute latent heat per gram of solvent, not per mole of solvent. Okay. So this is our first colligative property, elevation in boiling. Similarly, the second colligative property, depression in freezing point. So here what we are saying similarly, that freezing point of a solution is always less than freezing point of pure solid. So like if freezing point of pure water is 0 degree, then if we put salt in water, its freezing point will be lesser than 0 degree. Okay. And again, the difference here, delta T is given by a similar formula. Delta T is KFMI, where M again is molality of solution. I is Van Hoff factor. And Kf is molar freezing point depression constant. Or cryoscopic constant. And again, its expression is given by Kf is RT naught square by 1000 LS, where R is universal gas constant. T naught is normal freezing point of pure solvent, and LF is latent heat of fusion per gram of solvent. So these are our first two colligative properties. Elevation in boiling point and depression in freezing point. Okay. So let's take a few examples on these. from our PYQ main. So let's take our first example like this. First example we can take like this. Solute A is given. It associates in water. Solute A associates in water. When 0.7 gram of A is dissolved in 42 grams of water. When 0.7 grams of A is dissolved in 42 grams of water, the freezing point lowers by 0.2%. The freezing point lowers by 0.2 degrees centigrade. The percentage association of A's are molar mass of A is given 93 and Kf is given 1.8. Find percentage association of A given molecular weight of A 93, Kf 1.8. I will give you a minute to go through the problem and make your approach, then I will solve it. Okay, let's discuss this problem out. So here, let's see the data given to us. Delta T is given to us. Correct? Delta T is given to us 0.2 degrees centigrade. Kf is given to us. Molar mass is given to us. Correct? So let's apply in this equation. Delta T is equal to Kf and correct? Delta T 0.2 degrees. Kf 1.86. Molality. How we defined molality? Molality we defined as moles of solute upon mass of solvent in kg. So how many moles of solute? Weight of solute 0.7 grams. by molar mass 93 upon mass of solvent in kgs 42 by 1000 into Van 't Hoff factor I. So from here we can simplify this point to 1.86 into 0.7 by 93 into 1000 by 42. So 0.2 is equal to 186 into 7 by 93 into 42 into I. So this becomes 2, this becomes 6, 3. So Van 't Hoff factor we get as 0.6. Here. So now once we have got Van 't Hoff factor, this will be 1 plus y minus 1 into alpha. So 0.6 is 1 minus half alpha. So alpha we get 80%. Okay. Next example, let's see. Next example also we can take similar of colligative properties using font only. Let's take an integer type. How much NaCl must be added to 600 grams of water? Must be added to 600 grams water to lower its freezing point to minus 0.2 degrees centigrade. And you are given K for this problem as 2. So take a minute to form your approach. Quite a straightforward problem. How we will proceed here? Delta T, we know we want 0.2. Kf is given to molality. NaCl ke moles, let's take N. Weight of water in kgs 0.6. And Van 't Hoff factor for NaCl we can take 2 because we know NaCl is almost 100% ionized solid. Okay. So from here, how much we will get N? 0.2 into 0.6 by 4. Correct? So moles of NaCl we get 0.03. And then you can calculate mass of NaCl. 0.03 into molar mass of NaCl 58. Okay. So in this way you can do. Another such example, let's take when 3 gram of substance X when 3 grams of substance X is dissolved in 100 grams of CCl4. It raises its boiling point by 0.6 degrees Celsius. Molar mass of X is molar mass of X is, and Kb value of CCl4 is given to you as 5. Try to make an approach of this problem. Okay. So how we proceed in this problem? Increase in boiling point delta T is given to us as 0.6. Kb is given 5. Molality, moles of substance X, we can write as given mass is 3 grams by molar mass of X upon weight of solvent in kg is 0.2. Now here one thing you should know. Here the solute is given as X. We do not know what is solute, correct? So here, when we do not know what is solute, solute is given in such unknown form, then what we do? We will always take Van't-Hoff factors in such cases to be 1. Because we do not know how will this solute dissociate or whether it will dissociate or associate or not. Correct? So in such cases, we will take Van't-Hoff factor to be 1. So now very simply we can solve. Molar mass of X becomes 5 into 3 upon 0.6 into 0.1. Correct? So how much will this become? 300, 250. Correct? Next one example, let's take like this. These two examples, these are not PYQs, but these are good problems, and these type of problems might come. Let's say 0.1 molar solution of, let's say, COCl3 dot XNH3 shows a depression of 0.558 0.558 degrees centigrade. Okay. If coordination number of complex is 6 and it is 100% ionized, then find X. And Kf of water is given 1.8. Take a minute to think. Okay. So now let's see how we deal with such kind of problem. Now here delta T is given to you. Alpha is given to you. Kf is known. Molality is known. But you are not sure or you do not know what is the molecular formula of solid. That you need to find out. Okay. How we can proceed on such a problem. So let's first apply our relation. Delta T is equal to KFA, right? Delta T is 0.558. Kf is 1.86. Molality is 0.1 into Van't factor. So we get Van't factor from here as 3. And this should be equal to 1 plus y minus 1. And alpha is given 100%, that is 1. So from here y also we get as 3. Means this complex, when it is ionizing inside the water in the solution, it is giving us 3 particles. Another thing we are given that coordination number of complex is 6. Means this complex is making 6 coordinate bonds. Correct? Now the things attached to the cation CO3 plus R. What all things are attached with CO3 plus in this compound? Cl minus and NH3. Now Cl minus, as you know, can make ionic bond as well as covalent bond with CO3 plus. But ammonia can only make coordinate bond. So what can be the possible formulae of this compound? So suppose I assume that all 3 chlorines are making ionic bond. Then all the coordinate bonds have to be made by ammonia. So then the formula of this compound will be CO NH36 Cl3. I will need 6 ammonia to make 6 coordinate bonds. Because I have assumed that all 3 chlorines are making ionic bonds. Now the next situation can be that out of 3 chlorines, only 2 are making ionic bond and 1 is making coordinate bond. Then the formula will become CO NH35Cl Cl2. Now here 2 chlorines are making ionic bond, 1 chlorine is making coordinate bond, and for the remaining 5 coordinate bond we need 5 ammonia. Similarly, the next situation can be that out of 3 chlorines, 2 chlorines are making coordinate and only 1 is making ionic. So then the formula would become CO NH34 Cl2Cl. So here out of 3, 2 chlorines are making coordinate bond. So for remaining 4 coordinate bond, we need 4 ammonia. And last situation can be that all the 3 chlorines are making coordinate bond. So then the formula will become CONH3 thrice Cl. Okay. Now we should know that in such complex compounds, whenever we dissolve them in water, only the ionic bonds of the complex break in water. Coordinate bonds of the complex do not break in water. Correct? So if this is the situation, these 3 chlorine ions will break. So we will get 3 chloride ions and 1 this remaining whole cation. So in this case, Y would be 4. Similarly, here Y would be 3. Here Y would be 2. And here Y would be 1. Now by our calculation, we have got Y3. It means this is our compound. And here we can see the value of ammonia. The number of ammonia, that is X, will be 5. Okay? So I hope this type of problem is clear to you. Okay. Next, let's move to our third property. That is osmotic pressure. First of all, let's write what is the phenomena of osmosis. What is phenomena of osmosis? It is the net flow of solvent molecules from a dilute solution to a concentrated solution when these solutions are separated by a semi-permeable membrane. So semi-permeable membrane here means we have placed a membrane between these two solutions, which allows passage only to solvent molecules, not to solute molecules. Okay. So only solvent molecules can pass through the membrane. Solute molecules cannot pass. So this is the situation here. So let's say in a beaker, we have two solutions which are separated by a semi-permeable membrane. Let's say the molarity or the concentration of both the solutions is different. And let's say for sake of discussion, let's say C1 is greater than C2. Means on the left side, we have a concentrated solution. On right side, we have a dilute solution. Now what will happen? There is a membrane between them. And the membrane is semi-permeable. Means membrane will not allow solute molecules to cross over on each other side. But solvent molecules from both sides will cross over to enter the other side. Now the right solution here, the C2 solution, is a concentrated solution. Means on the right side, the concentration or number of solvent molecules is more as compared to left side. So what will happen? Solvent molecules will go from right side to left side, as well as from left side to right side. But since the number or the concentration of solvent molecules is higher on the right side, the number of solvent molecules crossing from right to left will be greater than number of solvent molecules crossing from left to right. Okay. And therefore, what we have written as our definition, it is the net flow. See, flow occurs both sides. Flow occurs from dilute to concentrated as well as from concentrated to dilute. Flow occurs on both sides. But the net flow occurs from dilute to concentrated. Correct? So this is phenomena of osmosis. Now what is our colligative property here? Colligative property here is osmotic pressure. What do we mean by osmotic pressure? How we are defining osmotic pressure? Osmotic pressure we are defining as the pressure that needs to be applied on a solution to stop osmosis into it when it is placed across pure solvent. Means, now I have taken a beaker with a semi-permeable membrane. On one side is some solution and on other side is pure solvent. So now, if we would have left this situation like this, osmosis will occur from the solvent towards the solution, or in net water molecules will flow from water or solvent molecules will flow from the solvent to solution. But in such case, if I apply some pressure over this solution, at some particular value of pressure, the osmosis will stop. Whatever that value of pressure is, that we will call as osmotic pressure. So if we apply pressure equal to osmotic pressure over this solution, osmosis will stop. If we apply pressure greater than osmotic pressure on this solution, then reverse osmosis will start to happen. Then the solvent will flow from the solution towards pure solvent, net flow. Correct? And that is our technique in RO water purifiers, reverse osmosis. Correct? And how is osmotic pressure given by? So osmotic pressure generally we will denote by pi. And osmotic pressure pi is given as ICRT, where I is Van off factor and C here is molarity of the solution. R, you all know, universal gas constant, and T is absolute temperature. That is temperature in Kelvin. So this is how we define our third colligative property, that is osmotic pressure. And the fourth colligative property is lowering of vapor pressure. What was vapor pressure? You remember? It is the pressure exerted by vapors of a liquid which are in equilibrium with the liquid. So what is fourth colligative property telling us? That vapor pressure of solution will be always less than vapor pressure of pure solvent. Okay. And this lowering of vapor pressure is mathematically given by Raoult's law. Which states that Raoult's law states that relative lowering of vapor pressure is equal to mole fraction of solute. Okay. So let's say we have some pure solvent in a beaker and the pressure over liquid by its vapor is, let's say, P naught, pure solvent pressure. Okay. And in another beaker, we have some solute dissolved in this solvent and we have a solution. Let's say pressure over this solution is Pn. So what is Raoult's law saying? Lowering of vapor pressure is how much? Lowering is this, P naught minus Ps. So Raoult's law is saying that relative lowering of vapor pressure, that is P naught minus Ps upon P naught, this is equal to mole fraction of solute, which you can take as I multiplied by moles of solute upon I multiplied by moles of solute plus moles of solute. Generally, moles of solute are much lesser than moles of solvent. So in the denominator, generally we can neglect I in solute term in comparison to N solvent. Okay. So let's see a few examples on these two properties, that is lowering of vapor pressure and osmotic pressure. So first example, let's take like this. That 12 grams of a non-volatile solute non-volatile solute dissolved in 108 grams of water causes a relative lowering of 0.1 in vapor pressure. Find molecular weight of solid. So lowering of vapor pressure का problem है. How we will approach in this problem? So your relative lowering is directly given to us. Relative lowering is directly given to us as 0.1. And this should be equal to mole fraction of solute. Now again you can see here, what is solute is not given to us. The identity of solute is unknown. So in such case, what will be Vent-Off factor? In such case, we will not take any Vent-Off factor, or we will take Vent-Off factor to be 1. So this formula will become moles of solute, 12 by molar mass, let's say M, upon 12 by M, plus 108 by 80. Correct? Let's take a reciprocal on both sides. So 10 is equal to 1 plus 6 upon 12 plus M. Or this equation will become 9 is equal to M by 2. So molar mass we get as 80. Okay. चलो एक नेक्स्ट प्रॉब्लम ऐसा लेते हैं. For a dilute solution, 2.5 grams of a non-electrolyte is dissolved in 100 grams water. Okay. So 2.5 grams electrolyte को 100 gram water में dissolve किया. The elevation of boiling point is elevation of boiling point is 2 degrees, and assume that concentration of solute is much lesser than solvent. Then find vapor pressure of this solution at 100 degrees centigrade. Try to think for a minute. Two properties have been combined here. Kb value is given. Kb value of water is given 0.76. So let's see here how we'll proceed. First, let's apply the boiling point concept. So delta T for boiling point is given how much? 2 degree. This should be kbmi. Kb is given 0.76 and molecular weight of solute is not given. Mass is given, correct? So 2.5 by molar mass upon mass of solvent in kgs, 0.1 gram. And we are given that it is a non-electrolyte. Means it is not dissociating into iron. So Van't factor 1. So from here molar mass we get 0.76 into 25 by 2. 0.38 into 25. Correct? How much will this become? 38 by 4. Correct? 9.5. We get as molar mass. Now we are asked find the vapor pressure. Pure water at 100 degrees has a vapor pressure of 760 minus PS upon 760. This should be equal to mole fraction of solute. And problem has already told us that assume concentration of solute is much lesser. So mole fraction here we will write moles of solute 2.5 by 9.5. And in denominator we will neglect moles of solute and we will only write moles of solvent, that is 1000 by 80. Correct? So by solving this expression, we can get the value of PS. So how much will roughly PS come? Let's see. This LHS term will become how much? 2.5 divided by 9.5. 2.26 roughly. Correct? This whole thing 736. So PS will be around 40. 724. Okay. So one more problem, let's take. So osmotic pressure of blood is 7.47 bar. This is given to us. To inject a glucose to a patient, to inject glucose to a patient, it should be isotonic with blood. Okay. Isotonic means two solutions whose osmotic pressure is same. Find concentration of glucose in grams per liter. In the solution, what should be concentration of glucose in grams per liter? Temperature is given 300 Kelvin. Can we do this problem? Now here we need a solution of glucose which is isotonic with blood. Means their osmotic pressure has to be same. Osmotic pressure of blood is 7.47. So osmotic pressure of this glucose solution also we need 7.47. So what will be our equation? 7.47 is equal to, for glucose went off factor will remain 1. Molarity we need to find. R in bar we can take 0.083 and temperature is 300. So C we get as 7.47 by 24.9. Correct? But this is in moles per liter. So in grams per liter, 7.47 by 24.9 into 180 molar mass of glucose. Correct? So that will give us the concentration of glucose in grams per liter. So how much will this become? 54. Exactly cancel. This is cancelling out 3 times. Correct? So this wraps up our colligative property part. In the next session, we will take ideal binary solution. Bye everybody.